Okay, on section 6.2, just so that you guys know, we're only going to do this over one day because it's pretty short, where we don't have to spend 2 days on it. Okay, we'll get everything done in one day and it'll be pretty fast. All right, so what you're going to learn or look at today is going to be what they call the natural base number. If I were to give you a formula like this and ask you to do 1 over 1 or plus 1 over x raised to the x, and do a table of values. And what I mean by that is start plugging in numbers. You're going to come up with a number very close to, or eventually, the higher you get, it's going to converge on a certain number. That number is called the natural base number. And in math, we don't necessarily want to use this big honking chunky formula. In this particular problem, we're actually going to not use the 1 over 1, or 1 plus 1 over x. We're actually going to use a letter to represent that whole thing. And that whole thing, do you remember way back when, the beginning of the year, when I said, I don't care what letter you choose except for stay away from these 4? Do you remember which 4 I told you to stay away from? I was one of them. O was one of them.
H?
No, not H is fine. I, because we've already dealt with I. Remember we had square root of negative 1. O, because it looked like 0. L, because it looked like a 1, right? And E. E is the one that we're going to use today. E is a number. I want you to, on your calculators right now, in your groups, quick take a look on your calculators and find E. Specifically to e to the x. And once you find it, now E on your calculators, and there are a couple different places, but I want the lowercase version, not the uppercase version. So once you find it, help your group out. Tell each other where it is.
Top above. Oh, okay. Did you second divide them?
I just told my math teacher last year it was really bad. I never learned any of this.
E to the x. Where did you find it?
Second long.
Okay, on the left side, right? About the third button up, and Dylan even was more specifically, it's got to be second in the LN button. You see where it says LN? It's right above that one. Okay, that's the button, and if it's in blue or yellow, depending on whatever kind of calculator you have, you will have to hit the blue or yellow button in order to get that first. So e to the x, lowercase e that is, stands for the natural base number. And that's what we're going to look at today. Now, what they're going to have you do on the first ones are going to be this. It's going to say e to the third times e to the sixth. And they're going to ask you to simplify that. Now, you don't need your calculators for this part. If you notice, I'm multiplying two things, bless you, that are the same base. What do you do with exponents when they're the same base when you're multiplying? Good. What's 3 plus 6? 9. Awesome. So the base stays the same as e to the ninth, and you're done. Okay? If I have 16 e to the fifth over 4 e to the fourth, how do I simplify that? Okay, I divide the 16 and 4 to make what? 4. And then what about the e again? I didn't hear you all the way, Jordan. You subtract them. And 5 minus 4 is 1. What if it would have been more on the bottom? Would I kept the e in the bottom then?
Yes.
Yeah. What do you think so far? Not too bad? What do you do if you've got the square root of 25 e to the 4x? What do you do?
Would you square it like a regular number first or no?
Okay, Jalen is asking would I square root the regular number first. What do you guys think? Yeah, I agree. So what this could do is it could do this. You could go the square root of 25 and the square root of e to the 4x. You can take them out individually like that. That is perfectly fine. Anybody know what the square root of 25 is? Awesome. Now, square rooting e to the 4x. There's a couple different roots to take, but this is probably the easiest one. In the beginning of chapter 5, we dealt with changing square root into fractional exponents. Square root was the same as what fraction? A half. So really that could be like me saying e to the 4x raised to the half power. When I have a power to a power, what do I do with the exponents? I multiply them. What's 4 times a half? 2. And I'm done. Last one like this, and then we're going to move on to the next part. Anybody have any idea? How do I do this one? Okay, when it's power to a product like this, we're going to multiply. Here's part that a lot of you forgot. Remember when we did this in chapter 5, was this 2 needs to also go to the 3. What's 3 squared? 9. And then when I go into here, which was multiply, which you were right, what's negative 4x times 2? Now, are you allowed to have negative exponents? No.
Wait, wouldn't the x be squared?
No. Because you're multiplying those, you're not saying x and x. You're
Oh, right.
okay. So now if this is over 1, what part of this goes downstairs? Just the e, not the 9. So just the e goes down. The 9 stays put. And we're done. What do you think? Okay, this is about the first third, even close to probably more than that of your assignment. Just doing this. Are you guys comfortable? Okay. Now, the next part is, if I were to ask you to graph these, are you able to graph them?
Yeah.
How?
Put them in the calculator.
Can you put them in the calculator to get the picture?
Yeah.
Sure you can. Could you physically put in numbers for x and get random numbers for y then? And plot order pairs and connect the dots?
Yeah.
Yes. If I asked you to give me a table of values, could you do it?
Yeah.
Yes. Just in case you weren't aware of this. This happened last hour where someone just had an aha moment. When you type in e to the x on y equals, instead of hitting graph, right above graph it says the word what? Table. If you hit second and graph, that gives you a table of values. So you don't physically need to actually type any of them in yourself. You can let the calculator do it all for you. So if I ask you ever to give me a table of values, that's what I would do if I were you. Now, what did it look like? Was it growth or decay? How'd you know?
Because it goes up.
Yeah, it goes up. It goes something like this, right? Hey, what number does it cross through again? 1. Because remember, anything to the 0 power is 1. Then the other one I'm going to ask you to graph. Y equals e to the negative x. Trent, did you put it in there? The second one? Yeah. I saw you were typing. I didn't know if you had it or not. Why? It's coming down? Okay. So it looks like it comes down this way and goes and rides out that way. Is that about right? Close to it? Now, here's why I knew it was a decay like that before you guys even graphed it. Not because I knew what the problem was, but also because of this. What's the difference between the left-hand graph and the right-hand graph? The exponent. And in the exponent, we have a negative. Do you remember when we did transformations like 14 billion times already this year? When we do transformations, when we have a negative inside with the x, that was a reflection over the y-axis. So if you take the original graph, the one that's on the left here, if you were to flip it over the y-axis, look, it would create this, wouldn't it? So me personally, how I got it was just by looking at transformations. Although you got it with your graphic calculator, but I wanted you to see that. That's how things could work if you need to. If you are capable of it, or if they ask you to graph it, here's what they're going to ask you to do. Is this a growth or decay? Sketch the graph. Have you heard those directions before? Yeah. 2 assignments ago, that's what you guys had. Do you need me to do any of those? Are you sure? Okay. Then the last thing that they're going to ask you to do is they're going to ask you to do something like this, and they're going to use this formula. A equals PRT. PERT. This is compounded continuously. Yesterday, the formula I gave you was for compounding at different intervals, like compounding quarterly, monthly, daily, yearly, stuff like that. This is compounded continuously. Have you ever, in another class, maybe looked up the national debt calculator? If you never have, check it out one time. What it will do is you'll see a thing just spin. That's an example of continuously. Because it just keeps going as fast as I can snap my fingers. It just keeps running every time. It never stops. All right? If you ever have a bank say that they want to compound something continuously for you, please let me know that too, because I would like to make more money also. All right? No. Theirs is quarterly. So yesterday, Gabby, I think it was you.
What?
How much money did you get in graduation money yesterday? Do you remember? Was it 3,000?
3,000.
3,000? So 3,000 was the principal. What was the rate I put? 2%?
Yeah.
0.02? And how much time passed before you retired? Is it 50 years? Huh? Okay. So the only difference is, notice that I don't have as much work to do with this, do I? I just have 3,000E. I put in the 0.02 because that was the rate that the bank was going to give her. And I put in 50 for the time in years. Everything about it's the same. When you type this into your calculator, depending on the age of your calculator, 3,000, you could do this when you have the E. Some of you will have a shadow box if you're a newer style, and some of you will have a caret. If you are the shadow box, you can just put in 0.02 times 50 up there without parentheses and hit enter, and you got the answer. If you're like the bottom one, Emma, for sure, because you're 83, when you have a parenthesis like that, you'd have to go 0.02 and then time sign 50. Do not close out the parenthesis till after you type the 50. Kristen, same way. At the bottom one. Okay, when you find your E. And Nicole. So when you type enter after that, how much money is in the account now?
I got 153,000.
Yeah. Can I have that money? 153,000.
I think the majority of you got this, right?
Yeah.
And I'm looking over Miss Thompson's shoulder, and that's what I watched her, or identified her typing it in. She did everything. 0.02.
Yeah.
Holy cow. 20% is a big deal compared to 2%, isn't it?
You want that money?
I would love that money. Okay?
I want that money. I need
So,
those.
here's what I want you to quick do for me, though. Look back at yesterday's notes. How much money did she make yesterday?
Not enough. Or maybe more. I don't know.
She made And we must have typed something in on it yesterday. Are you sure it was 50 years yesterday?
51.
Oh, that's a difference. That's why, okay? Who said 50?
I didn't even know my own age. I didn't even know I had money.
All right. We need to change this to 51, you guys. I want to show you something with this. That's why. So rerun that thing, but change it to 51, not 50. 8,319, and how much change, guys? Okay? All right, so now, if Gabby were to put it in that kind of account, she has $8,319 and some change. Yesterday we had $8,248 and some change, right? 98? 498? Is that what it was?
Yeah, no.
And no sense? Okay, just check. So, notice the difference. Is it more money? Yeah. Is it a lot more money? Not really. It's 20 bucks. Okay, but the key is you were never adding anything more into that, and the fact that $3,000 in the grand scheme of things is not a whole lot of money. If you were dealing with more money, like when you typed it in wrong, then we would see a bigger significant change. Okay? So just so that you guys know, you'll see a bigger change if you have more money going in. What do you think of that problem?
Not too hard.
Not too hard. Just plug in the number and see what you get.
I want to see what that'll put out.
Just don't forget me. So, on page, I think it's on 307 and 308. Or 3 to 21 odd and 35.